On a clear summer morning, a single flash of light appeared in the sky brighter than 1,000 suns. In that instant, an entire city was engulfed by a wave of unimaginable force. This was not a natural event, but something born from human ingenuity and desperation. It was the dawn of a new age, an age defined by a terrible and awesome power held within the smallest particles of matter. The world would never be the same again. The events of that day brought a swift end to the most destructive war in human history, but they also cast a long shadow over the future of all life on our planet, posing a question that we are still trying to answer today. The story of the atomic bomb is not just one of science of warfare, but also of human ambition and fear. To understand this moment, we must look back at the years leading up to it, a time when the world was torn apart by conflict. The journey to that fateful day began years earlier, in the deep secrecy of a program known as the Manhattan Project. Launched in 1942, this was an unprecedented effort, bringing together some of the brightest scientific minds from around the world. Their task was urgent and shrouded in mystery, to build a weapon based on new discoveries in nuclear physics. The fear was that Nazi Germany might develop such a weapon first, driving the Allies to pour immense resources into this secret race. Hidden away in remote locations across the United States, Los Alamos, Oak Ridge, Hanford, scientists and engineers worked relentlessly against the clock. The timeline is marked by key milestones that pushed the world closer to the nuclear age. After years of theory and complex engineering, the project reached its critical test phase. On a remote patch of desert in New Mexico, on July 16, 1945, the first atomic device was detonated. This event, known as the Trinity test, was a moment of terrifying success. Scientists watched a colossal fireball, then a mushroom cloud climb miles into the atmosphere. The tests proved their theories correct. They had unlocked the atom's power, and the world now possessed a weapon of unparalleled force. With the war in Europe over, focus shifted to the Pacific Theater. U.S. leaders, wanting to avoid a costly invasion of Japan, decided to use the new weapon. The 7 minutes that encompassed the bombing of Hiroshima were a study in swift and total devastation. From the moment the bomb was released from the Enola Gay to the point where its primary destructive energy had been spent, the nature of conflict was redefined. For the crew of the aircraft, they saw a brilliant flash and felt the shockwave, even from miles away. But for the people below, it was an experience beyond comprehension. A searing light filled the sky, followed by a wave of intense heat that vaporized everything near the hypocenter and caused severe burns to people over a mile away. Immediately following the heat wave came a powerful blast, a shock wave that radiated outward at supersonic speed. This immense pressure flattened buildings, shattered infrastructure, turned everyday objects into deadly projectiles. Most of the city's structures were made of wood and paper, and they were instantly obliterated. Reinforced concrete buildings were gutted, their frames left standing as skeletal reminders of the city that once was. The force was so great that it created a powerful wind that reversed direction, rushing back toward the center of the explosion and feeding the growing fires with oxygen. In the aftermath of the initial blast, a new horror emerged. A towering mushroom cloud, dust, debris, radioactive particles rose high into the stratosphere. At the heart of this immense destructive force lies a surprisingly simple scientific principle. All matter in our universe is composed of incredibly tiny particles called atoms. These atoms are like miniature solar systems, with a dense core, or nucleus, at their center. This nucleus is made up of even smaller particles, protons, neutrons, all bound together by a powerful force. For most elements, this bond is very stable. However, in certain heavy elements, such as specific types of uranium, plutonium, the nucleus is large and somewhat unstable, holding a tremendous amount of stored energy. The process that unlocks this energy is known as nuclear fission. The word fission simply means to split apart. In an atomic bomb, this process is started by firing a single neutron, like a tiny bullet, into the nucleus of a heavy atom, such as uranium-235. The neutron strikes the nucleus. The nucleus becomes highly unstable and splits into two smaller nuclei. That split releases a vast amount of energy in the form of heat. Light. It also releases 2 or 3 additional neutrons, which fly off at high speed. This is where the chain reaction begins. The new neutrons go on to strike other nearby uranium nuclei. Each struck nucleus splits, releasing more energy and yet more neutrons. The number of splitting atoms doubles and redoubles at an astonishing speed. In less than a millionth of a second, an uncontrollable cascade of fission events occurs, releasing a colossal amount of energy from a small amount of material. They designed subcritical masses and used conventional explosives to slam them together, forming a supercritical mass and triggering the blinding flash, the searing heat, the crushing blast wave. The immediate impact on the human population was catastrophic. A lone, damaged child's tricycle sits among the rubble. In Hiroshima, tens of thousands were killed instantly. In Nagasaki, tens of thousands were killed instantly. Those closest to the hypocenter were vaporized by the extreme heat. Others perished in the collapse of buildings. Others were caught in the firestorms that raged through the cities. The survivors, the Hibakusha, faced a living nightmare. They emerged into darkness, dust, and ruin. One survivor, Akihiro Takahashi, recalled,
"The heat was tremendous, and I felt like my body was burning all over. For my burning body, I jumped into the river, and I think I was there for a couple of hours. At a glance, I saw something black floating in the river. I couldn't tell what it was. I thought it was a log. But it was a dead body."
Hospitals were destroyed. Doctors and nurses were among the dead. Medical supplies were non-existent, leaving the wounded with little hope. A new and terrifying sickness appeared. Radiation sickness, hair loss, severe bleeding, immune collapse. Many died slowly and painfully in the months that followed. For decades, survivors faced higher cancer risks and lasting trauma. The atomic explosions did more than just destroy 2 cities. They fundamentally reshaped the landscape of global politics. With the demonstration of this new weapon, the United States emerged as the world's sole nuclear power, a position of unprecedented military advantage. This monopoly, however, was short-lived. The secret of the atom could not be contained, and the Soviet Union accelerated its program. In 1949, the Soviets tested their first bomb, igniting the nuclear arms race. A new era of global tension began, the Cold War. International relations shifted dramatically. Superpowers and other nations amassed vast arsenals, many times more powerful than the bombs dropped on Japan. Strategy moved from winning wars to deterring them. The doctrine of mutually assured destruction emerged. The fear of nuclear war permeated daily life. The bomb became a cultural symbol of triumph and terror. Anxiety fueled global movements for disarmament. Scientists, activists, citizens pushing for limits on testing and proliferation. Meanwhile, peaceful applications of nuclear science emerged, power generation and medicine, underscoring its dual nature. The power of the atom remade our world and placed profound responsibilities on our shoulders. Today, 8 decades after those fateful days in August 1945, the legacy of the atomic bomb continues to shape our world. The immediate horror of Hiroshima and Nagasaki, and the accounts of the survivors passed down through generations, are urgent messages for the present. They remind us that behind strategy and geopolitics lies an immense capacity for human suffering. The power we have unlocked demands utmost caution and a deep sense of moral responsibility. The threat of a global exchange has receded, but danger remains. Weapons still exist, knowledge is widespread, and new tensions remind us peace is fragile. Beyond treaties and inspections, we need dialogue, empathy, and a shared desire for survival. The story of the atomic bomb is ultimately a story about choice. The same science that created the bomb powers our cities and saves lives. Knowledge is neutral. Its moral character is defined by how we use it. New breakthroughs in genetics, artificial intelligence, and environmental science demand wisdom and foresight. By honoring the victims and choosing cooperation over conflict, we can ensure such a weapon is never used again. The choice, as always, rests with us.